capture direct. But all right, we're rolling.
Okay, we are ready.
That's what we got to do.
Okay.
Maybe Jason.
Hey, everyone having a good Derbycon so far? Yeah. Sweet. Okay. So, as you're probably aware from the talk title, we're going to be covering my approach into solving the tradecraft problem, the red team tradecraft problem of dynamically accessing .NET, because .NET gives us all the goodies, right? The post-exploitation on Windows, that's what we want. And that's why, at the end of the day, that's why PowerShell is still such a big deal in terms of offensive tradecraft, is because it allows us to access .NET and, do shellcode injection and inject mimikatz and all the stuff that we all like as red teamers and pen testers, right? So, warning, also I have to try not to move around a lot, which is a problem. But there is some C# and Python code ahead, but I will try my best to explain everything as much as I can, because I'm going to assume that some of you don't know C# and or .NET. So I'll do my best to try to explain it. We're going to start with just the general motivation of why I even tried to do this. We're going to go down the rabbit hole of just how all of the tears, sweat, and drinks that I had to have to even get this working. And we're going to talk about how I weaponized it. We're going to do a live demo. Everyone start praying to the demo gods. And conclusion and some takeaways from all this stuff. So let's just get right into it. This is my name is Marcello. I go by Bike Leader on Twitter. I work for Black Hills. They're kind enough to sponsor me and do all this great stuff, send me out to these conferences. That's the link to my GitHub. If you want to come talk after or before or after, I guess the talk, we can't go back in time. After this talk, I'm at the Black Hills booth, so if you want to come around and talk to me there, I'm all for that. So let's start with why even try to do this, right? Well, PowerShell, it's sort of dead. It's not really dead. Like, in terms of at least offensive tradecraft, right? It's sort of like a zombie. It's not completely dead because there's still environments that, you can just run PowerShell v2 and you're good to go, and some environments that just don't have the latest version of PowerShell installed, which has all the defenses. So it's a hit or miss. But at least at Black Hills, we have most of our clients do only run Windows 10 most of the time, and so they have the latest and greatest stuff in terms of EDR solutions. And so we sort of have to improvise a lot of the time, right? So, and like I said, like usually our clients have Windows 10, PowerShell version 4 or greater, which has AMSI, they have constrained language mode, most of the time they have module script block logging or transcription logging, whatever they see fit. So how do we get around this? Well, up until now, you can obfuscate, right, with using something like invoke obfuscation, which is awesome. You can use some of the AMSI logging bypasses, right? But the problem with that is you have to obfuscate the bypasses because the bypasses themselves are signatured. So that's just another pain in the butt, really. Or use PowerShell v2, which sometimes I was surprised to see like how many environments actually have PowerShell v2 in Windows 10, which is really weird. Or just directly go to C#. And this has been sort of the go-to way of getting around this. And we've seen, like in the past year or so, like the great tooling migration to C#, right? So everything was PowerShell, now it's just everything is C#. And there's definitely some pro and cons to this. So the pros is by far it's the most direct solution in terms of tradecraft, right? Because if you're familiar with PowerShell, you'll find yourself at home at C#. The .NET framework is tightly integrated within Windows. Like I said before, like the reason why we like C# so much is PowerShell and C# so much is that because you can go as low as you want, you can go as high as you want. Like it really gives you lots of flexibility in terms of tradecraft. The cons is it's a compiled and strongly typed language, meaning that during like limited engagement windows, I personally don't want to compile stuff every 2 seconds and drop binaries to disk and all that stuff. And also .NET version modes, like if you compile something against a version of .NET, it's not going to be backwards compatible. So it's just a lot of stuff that I really don't want to deal with, especially if I'm on a limited engagement window, right? And also, I'm sort of a Python fanatic, and it's not Python or PowerShell, and I really like Python a lot. I have a problem. But so the whole reasoning behind this is I really just want something that can just work natively and is a scripting language, right? And the question from that, I guess the following question to that is, can I execute PowerShell code? This was the original, at least the original question, was can I execute PowerShell code without worrying about any of these defenses? I just want something that works. I just want to run some PowerShell code maybe on the system, on the endpoint, without worrying about any obfuscation, none of this stuff. I just want something to work. So, I'm a Python fan. So the first thing, I was committed at this point. I was so frustrated, I just want something that works, right? So first thing I did, since I'm a Python fan, how to run PowerShell with Python. And this turned out to be the best Google search of my life. So the second Google page result, which if you're on the second Google result page, you're already scraping the bottom of the barrel there. The second page result was a Python script called PowerSlim by this guy called, or woman, called Valskek. I hope I'm pronouncing that right. And I was looking at it, and I try it. I install, it was IronPython, but I never, up until this point, I didn't even know what IronPython was. So I just download IronPython and I run it, and it works. And I have a really bad habit of getting really excited about stuff without just taking a step back, calming myself down, and actually looking more objectively at what I'm seeing. So I immediately tweet about it. I have a problem. And I'm like, hey, this is cool. I can execute PowerShell in an unmanaged run space with Python, right? And then I'm like, okay, let's take a step back here and actually look at what we're seeing here, because I don't know how any of this actually worked. So I take a look at the first 4 lines, and I see import CLR. CLR add reference system.management. System.management automation. I'm like, okay, hold up, I've seen these before. Where have I seen this? Oh yeah, I've seen this in stuff like NPS, right? So, but not PowerShell. Like, this is just a way of creating, like, running PowerShell in an unmanaged run space. So that's kind of cool. So that obviously means that, like, stuff like NPS, or really any other tool that creates unmanaged run space, is the same, like, it's doing the same thing as this script called PowerSlim, right? So that's really, really cool. So you're telling me that I can just call .NET from Python. So I can have the power of PowerShell without going through PowerShell, because we're able to just dynamically call .NET APIs, right? In Python, like, I feel like I just died and got into heaven, right? Okay, I have no clue what's that all about, but let's move on. And so IronPython. So I start, and this is how this all started. I went down the rabbit hole, and so let's go down this rabbit hole together. So the first technical challenges I had coming into this, I had no knowledge of C# whatsoever. Like, I knew some of the basics, but the first challenge for obviously is going to be I'm going to have to learn C#. Second challenge is how do I set up a development environment for IronPython. Third is how can I get IronPython scripts to run natively on Windows? Because obviously I don't want, like, to social engineer the user into installing IronPython so I can run my stuff. That would be kind of weird. And to that point, like, can I possibly compile IronPython scripts to do that, right? So the goal really is native execution of IronPython scripts on Windows. So, which would be amazing, because that would be like a scripted interface to .NET, which would allow us, especially natively, which would allow us to just dynamically call these .NET functions, or .NET APIs, on Windows. So, I immediately, because was naive, but I tried PyInstaller and Python.exe, and Wampum does not work. Obviously, this is because, so PyInstaller and Python.exe, these frameworks which are meant to compile Python scripts to executables, are meant to be run on CPython, which is the C version of Python, as opposed to IronPython, which is based on .NET, right? So, right out the gate, this is like the easiest way I could think of to do it. It just doesn't work. So I'm like, okay, at this point, I'm just completely out of the realm of anything that I know. So I'm going to actually buy a book on IronPython. So I go on Amazon and I order like 20 books, which was very impulsive. As I said, I get excited about this stuff really fast. But really the only book that I really needed was this. And this is by far the most practical book on the subject. IronPython in Action. I think, if I recall correctly, it was actually written by the creators of IronPython. And it's, in terms of like practicality of the language, like this is the best book you can probably get. And setting up a development environment was actually quite straightforward. All you really need is IronPython, add it to your path. There's actually, so the current version of IronPython that's stable is Python 2, so it's based on Python 2. They're working on Python 3, but it's in the works. But definitely use the one on their website right now because the Python 3 version is a little, it's very much beta. So all you really need is Visual Studio, Visual Code, and the installer for IronPython. So I read the book in one night, and it left me more confused than I was before because I know nothing about C#. I still don't think I know that much about C#. And but there was this one part of the book that really got me interested. And that was, and they were talking about how to embed the IronPython engine within a C# binary, which sounded really cool. And the examples that they gave in the book was almost exactly what I wanted to have. So it was a native way of basically executing IronPython scripts through C#, which I thought was pretty amazing. And this is an excerpt from the book on the author's website, voidspace.org.uk. Most of the book that I just mentioned, by the way, is on his website. So if you don't want to buy the book, like most of the most practical examples are on his website. So the first thing, I just want to get this working, right? At this point, I just wanted something to work. And this is the simplest thing that I can come up with. So import CLR, which is basically how IronPython, how you can like add references to assemblies in IronPython, right? Import CLR, CLR add reference, systems, Windows Forms, and this just pops a message box. So you're just popping a message box. Pretty simple, right? So I just want this to run. I just want to see a message box. So apparently, all you really need to do, this is pretty simple, is reference the IronPython assemblies, which are provided by IronPython DLL, IronPython modules.dll, and Microsoft Dynamic Microsoft Scripting. The last two are signed by Microsoft, the first two are not. But all you really need to do is reference these 4 assemblies, and I'm going to try something fancy here that I've never tried before. Let's see if this works. Hey, look at that. Script engine, runtime create engine, which basically just embeds, like I said before, embeds the IronPython engine within a C# binary, and then engine.execute, and the myScript variable here is basically just the source file for your IronPython script. So you just give that myScript the source file, and it executes native IronPython, which is amazing. So obviously, my first sort of proof of concept, and I'm sorry if that's small, that's just a big one-liner, was just to run just a C# binary. You give it, as the first argument, you gave it a IronPython script on disk, and it would run it, and it worked, right? But obviously, in terms of tradecraft weaponization, you wouldn't want to drop like another file on disk with the source of your payload, right? So, and again, this was pretty new to me because, again, I knew nothing of C#. So it turns out in C#, all you really need to do is call getManifestResourceStream. You give it the name of a file that you can embed in the C# binary itself, and on runtime, it just gets the whatever data you embedded in the C# binary in Visual Studio. It's literally just embed resource in Visual Studio. It's pretty simple, and it will just read whatever resource you give it and put it in a variable. So that's great, right? So now we've embedded the IronPython script that we want to execute inside the C# binary itself, and when we run it, it pops the message box, and it worked. It was great. So now we have a C# binary that natively executes IronPython code, which is awesome. That's what we wanted, right? So let's go back to our technical challenges here. Learn C#, still work in progress. We got IronPython to natively execute scripts, but the problem now is how do we give access to the script within that engine to the Python standard library, right? Because obviously we'd want access to the Python standard library so we can like call all of those nice little libraries that we know and love in Python. And also the second problem was it needs third-party DLLs. So the IronPython DLLs and the Microsoft Dynamic Microsoft Scripting DLLs are not shipped by default on Windows 10. So that was also a problem as well, and I needed to figure out how to do that. Compiling IronPython scripts turned out to be not possible with the usual tools I was used to, but turns out that's possible as well, and I'll talk about that a little bit later if I have time. So I wanted to basically give access to the script that I execute within the engine to the Python standard library, right? And I worked on this for a long time, and to do this, I basically found an article from what I think was 2012 in the far reaches of Google that, and one of the authors, I think, of IronPython actually posted code to say, hey, like if you want to give access to the standard library of the script in the CSharp binary, you basically just have to embed the entire standard library in a zip file in this CSharp binary itself, and then call this magic function called resource metapath importer. And you give it the name of the resource that you embedded, and automatically it will take that resource, unzip it, it expects a zip file, load all of the Python files that are in that zip file in memory, and then all you need to do with that is append it to the sys path, so the system path of the engine itself. So really, the magic sauce here is this resource metapath importer function, where you give it the assembly name and then the resource name in your CSharp binary, and you're good to go. And you just append that to the system path. And I tried that, Wampum does not work. And I tried this for a long time, like a long time. I think I tried figuring out why it did not work for at least a week to 2 weeks. So 1 week later, I completely give up, and I am frustrated as all hell. And I decided, okay, obviously I don't know C# well enough to even try it. Like, I've tried everything possible, I don't know C# well enough, right? So I post a issue on the IronPython repository, and I'm like, hey, you know, I'm doing stuff which I think should be working. Why isn't it working? And I wasn't even expecting a response, to be perfectly honest. And the next day, one of the maintainers responded, can you try the latest release, which is 2.7.8? And 2.7.8, where's that at? It's not on the website. It's 2.7.7, it's the latest release. So it turns out they don't update their website. So I go to the GitHub page, and it's under the releases tab of the GitHub page. And at that point, I'm like, do you want me to like throttle you or something? Because this is how you get murdered. But hey, it works now. It works now. It's fine. It's all good. It actually worked. I literally just download the new version of IronPython, install it. I run the same code that I had before. It works perfectly. So I'm happy with luck right now. So now we solved the second problem. So we have access to the Python standard library for the script that we embedded within the C# binary, right? Using the IronPython engine. Now the problem is, which I thought was going to be a lot more complicated than this, was it needs the third-party DLLs, right? It needs those IronPython DLLs that are not shipped by default in the .NET framework. So I don't know C#, but even I knew about IL merge, and I thought, okay, this should be very straightforward, right? So I use IL merge, womp womp. Does not work. And I Google it, first thing that comes out is a Stack Overflow post that says, sadly, IL merge does not work with IronPython. So I'm like, well, crap. There goes that, I guess. But this guy is extremely useful. And he points me to a really, really old post by Geoffrey Richard, I think that's the way you pronounce it, and an excerpt from his CLR via C#, his book. And in this book, he detailed a very, very interesting way of dealing with this without IL merge. So to pack all third-party assemblies within a C# binary without using IL merge. And to do this, all you do is register a callback method with the app domains resolve assembly event. And he gives a little snippet of code which does exactly this. And what this code does is it basically, whenever you run a C# binary, and you can put this code basically anywhere, at least from just my testing. And what it'll do is it'll hook the assembly resolve event. And what that means is when the C# binary tries to resolve an assembly and it can't find it, it'll execute the function that you give it. So with this function, we can tell it, hey, if you don't find an assembly, just look for it in the embedded resources in the C# binary. Or fetch it from a URL, right? So we can just stage DLLs this way, or just pack them inside the C# binary themselves, and it'll just work. And so the next question is, like, if this exists, what's the point of IL merge, right? Like, I thought IL merge was supposed to solve this. Turns out, there is no point to IL merge. Because even the author of IL merge himself commented on this little episode here, and he says, hey, you know, this is absolutely amazing. If I had known about this, I never would have written IL merge. So that's pretty cool. So this is literally, let me see if I can go back to that. This is literally just a straight up way, a straight up better way of dealing with third-party assemblies and that. So that's pretty cool. I thought that was really, really cool. So going back to our technical challenges, right? So we pretty much took care of everything, but the problem is now it only works in .NET version 4.0, and this is because the compiled IronPython assemblies are compiled against .NET version 4.0. So they won't work on anything on any lesser versions than that, right? And I actually figured out a way around this. I just need a lot more time to do that, but it is possible. And it's not that big of a deal in my mind, to be perfectly honest, because the reason why you want to use this in the first place really is to get around the PowerShell protections. And if you're not on a Windows 10 machine, you should be able to use PowerShell stuff. So it's a hit or miss, but I figured out a way, and I'll talk about that later. So I get a proof of concept working, and I apologize this is small, but you get the point. It pops the message box, and it all works. So now we accomplished our goal, right? We have native execution of IronPython scripts on a Windows machine. So now we have access to entirety of .NET, and we've discovered some cool stuff along the way. We found a better way of creating Python executables for Windows, period, because this method is just straight up better than PyInstaller or Py2Exe. Like if you didn't care about the binary size, you can embed the entire standard library in the C# binary. You can embed your source file in the C# binary, run this single executable, and it'll just work on .NET version 4, on anything with .NET version 4. We just also discovered a lesser known way, and much better, as the author of IL merge stated, of creating a single exe that depends on third-party assemblies. So that's cool as well. And even if you're just a developer, I think this is pretty amazing. Like you can just natively, like you can write your application in IronPython and only have like a C# stub to deploy your application, which I think is pretty amazing. Like from even a developer standpoint, if you're not interested in security whatsoever. And again, like we accomplished our goal, but we have native IronPython script execution on Windows 10 through an embedded IronPython engine within a C# binary. But wait, there's more. We go deeper on this. It starts becoming like Inception. So how is this even possible, right? Well, it turns out there's the CLR, and then there's this thing that's on top of the CLR called the DLR. And before even this, I haven't never heard of the DLR before. But it turns out C# runs in the DLR, and all of the Iron languages run in the DLR. And the DLR is basically an interface for scripting languages to the CLR. And I still don't perfectly understand how this even works, let alone the internal details of this, but that seemed, from the documentation I read, I think that's pretty accurate. But there's a link in the slide, which I'll be releasing. So if you want to read up more about that, I sure will, because I still don't understand how everything works. You can definitely read there, and hopefully they explain it better than I did. So let's talk about weaponization. So now we have native IronPython script execution. Now we have to weaponize this, right? So we still have to learn C#, which is a problem. The file size. So in my original proof of concept, we embedded the standard library, we embedded the source file all in one binary. The problem with this was, if you embed the standard library, the binary becomes like 15 megabytes, which is not exactly ideal, offensively. If you compress that standard library to the max compression level that zip file allows. The binary becomes around 8 megabytes, which is still way too big. From an OPSEC perspective, I preferably do not want this to touch disk. That'd be great. And can we get this to work on .NET version 4.0, which we'll talk about if we have time. And now really the only thing we have to do is write a framework around it. Excuse me. And port some of the existing C# tooling that's been coming out to IronPython, which is really, really easy because it's the same function calls that you do in C#, only in Python, which is better. And all of the data type conversions between IronPython and C#. I thought that would initially be a problem, but it turns out it's pretty easy as well. So the question is now, do we, when I first started writing this, I thought to myself, well, do we really even need the Python standard library, right? Because we have access to .NET. So, like, we can just download stuff with .NET using, web request create. We can do everything that .NET does, only in Python. So, do we really need the Python standard library? I mean, in the long term, that would be great because it would be awesome to just, like, push responder down to it, run responder on a Windows 10 machine. That'd be kind of cool. But, like, initially, like, but you can stage it over the network. Like, you can stage the entire standard library over the network, and that's perfectly fine, if needed. So without the standard library, this becomes 10 kilobytes, which is much, much better. That's great. We can work with that. So I started writing, like, actual modules for the framework, right? And it's just amazing. Like, there's some IronPython examples online, which were almost, like, they're not even meant to be weaponized, but it's just amazing. Like, from a red team perspective, all the examples online are amazing. So the first one here, for example, you can just send down a C# assembly. It'll execute that assembly completely in memory, and it'll write the output to a buffer. We print out the buffer to the stdout, which we can capture in the embedded IronPython engine. And so this way, this is a perfect, and this is the ExecuteAssembly module, for example, the tool Silent Trinity that I'll be releasing. And just in 10 lines of code, we can do that in IronPython, and it's really, really cool. So if you want to write your own if you just want to write your own C# assemblies, you can just push them down, and it'll just execute completely in memory. You can also compile C# directly in IronPython via code DOM. So you can take all, like, for example, any C# tool that you think of, you can literally copy and paste the source code for C# into an IronPython file, and using this handy-dandy example, which the actual IronPython website has online, all you do is give it the C# source code, and it will dynamically compile that C# on the endpoint when you execute the function. And this is the equivalent of add type in PowerShell. Like, if you're familiar with add type, this is the exact equivalent. And you can pass, and it calls csc.exe in the background. So, there is an option for generate one of these the assembly in memory, but it does touch disk. It's a misnomer. But I digress. That's a whole different thing. But so you can just copy and paste C# code into an IronPython file, and it'll dynamically compile it on the endpoint. The equivalent of add type. Which means, this is the Mimikatz module in the tool. We can take the SafetyCats module, rather. So I ported SpectreOps' SafetyCats to IronPython. And we can just take a C#, either a C# assembly, not an assembly, or just paste in the source code that exposes the Win32 debug help mini dump write dump function, which is what we can call to actually create a memory dump of a specified process in Python. And then we just decompress a string in the same source file, which is just a compressed Mimikatz binary. We can then pass that to the sharpsploit PE loader function, which I've also ported to IronPython, and I'll just execute Mimikatz through an IronPython engine, through a C# assembly, natively on Windows 10, which I think is pretty amazing. And I think at this point, this is like even better than this is just beyond my expectations, to be perfectly honest, and I think in terms of post expectation, this is just peak right here. Like, you're writing your stuff in Python, which is a scripting language, and it's executing natively on Windows. I think this is pretty cool. There's also, there's interop with COM, like through IronPython. So you can, this is just an example that I got off the IronPython documentation. You can call COM objects, so the Excel COM object. So you can do stuff like inject shellcode through VBA macros in Excel, which is one of those techniques that Subti put out, through IronPython itself. All dynamically, all scripted through IronPython. So that was cool. And this is just a direct example from one of the websites online, which is just literally showing you, hey, you can just import CLR, import interrupt, call the Excel COM object, and do whatever you want at that point. And I've actually weaponized this, and there's a Excel shell inject module in the tool that I'll be releasing. But it goes even further. So you can embed, everyone stay with me here. I know this is, I'm struggling myself to explain this in a concise way. You can embed an IronPython engine within an IronPython engine within the C# binary. So like you can embed multiple IronPython engines within IronPython engines, which is awesome. Because what this does is, if you, for example, send down a job, right? So you want to execute an IronPython script on the Windows 10 machine. Instead of making it execute in the initial run space, what you can do is just spin up another IronPython engine, make that script execute in that engine, and when the script is done executing, the actual assemblies that the job you wanted to execute get unloaded in memory after it finishes executing. So, like for example, the Sharpsploit assemblies and all of that stuff that it needs to actually load Mimikatz and inject Mimikatz in memory and pull down credentials, that will get completely unloaded from memory on runtime after it finishes executing. And all you do is really just run it in a separate IronPython engine. And you can set the standard output instead of an error to just a stream, so that you capture the output of the module or the job you want to execute, right? Which is amazing. So I love the IronPython engine so much that I embedded an IronPython engine within an IronPython engine within a C# binary. That's kind of cool. So holy crap, right? So there's zero optics into any of this, and I've tried this on a couple of EDR solutions, and it goes through Defender like a breeze. EDR solutions, so if you properly instrument your payloads, you'll get by it. The problem is, like, if you start injecting shellcode and stuff, and you're using the standard Win32 API calls that you usually run, like, virtual, like that kind of stuff, to reflectively inject DLLs or inject shellcode, like, obviously that's from heuristic standpoint, that's easy to catch. So if you properly instrument your IronPython payloads, it just flies by everything. Because there's zero optics into CLR. I don't even know about the DLR. Like, I'm assuming, like, if you instrument optics into the CLR, it should automatically just give you access to the DLR, because it's it's the lower level. But I don't know enough about it to make that conclusion. Massive amounts of reflection, which is amazing from a red team point of view, because that means more evasion for us, right? So the more reflection, the better. Payload is decoupled from execution, which means that you can just, like, for example, weaponize some of the Subti's whitelisting bypasses that he's been putting out recently, like the MSBuild one, which works great on a number of whitelisting solutions. It goes by those. And you can have the logic of your payload completely decoupled from your actual stager, which is great. And your actual payload logic does not reside in memory. It only resides in memory, rather. Sorry, does not touch this. So you have a C# binary that's and this is the tool, Silent Trinity, that basically the actual Python logic of the payload gets staged over the network. So if the blue team, for example, went to decompile the actual C# binary, they would only see HTTP calls, or whatever COM you choose to use, to a certain URL. Like, the actual logic of the payload is not in the C# binary, because it gets staged at runtime over the network, which is amazing, right? Everything's dynamic and inscriptable, which means more productivity during red teams, and you don't have to compile your stuff all the time. And you're just sending a .py file over the network. That's really all it is. Like, you're just sending a Python source file over the network, which is text, and it's pretty awesome. And it's a .NET assembly, right? So, which means that it's extremely flexible in the way you can stage this. Like, you can stage this via .NET to JS, MSBuild, like all the stuff that's been coming out recently. And since each job, quote unquote, runs it in its own isolated IronPython engine, all of the assemblies that it needs get automatically unloaded afterwards. So it's stealthy, even memory-wise. And again, like the great thing about this is you can easily port over most of the C# tooling that's been coming out recently directly to IronPython with very few changes. Hell, you can, like there's one module which injects shellcode, MSIL shellcode injection, which hopefully will work. We'll see. I'll show you in a second. Which just basically I copied the source code for Xorior's C# version of this, put it in an IronPython file called the generate function, and it just works. Like you don't even have to port it over if you want, but I guess it would be a little bit more stealthy since compiling C# through IronPython leaves stuff on disk. So, demo time. Let's all worship the demo gods right now. Okay, so I wanted to build something. This took a while to build. This is actually not what I wanted to release. I was actually working on a team server implementation of this because I'm really tired of stuff that you can't really shell because red teams, like you collaborate with other people. But I didn't finish it in time, so I'm releasing only the standalone version of this. So this is Silent Trinity, and it's basically, the server side is written in Python, Python 3, and it's got some really modern UI features, which I really desperately wanted in one of these frameworks. It supports resource files, which is what I just did. I just tacked on -r, gave it a resource file, and it automatically runs whatever commands are in that resource file. It's got some really cool auto-completion features like that. That's kind of cool. It shows you all the commands that are available. I'm going to spin this up real quick. Perfect. Okay. So there are a couple of stagers implemented within Silent Trinity. Right now, there's the Wimic stager, which dynamically injects the C# assembly, Silent Trinity assembly, using .NET to JS with XSL files using Wimic, which is one of Subt's methods. And there's the MSBuild method, which stages it via an inline C# task with MSBuild. And I'm going to show you that one. I already generated one because I don't trust the demo gods enough to do this twice. So, and I put it on the VM, and now I'm just going to execute it. So I'm just calling msbuild.exe, giving it the XML file that I have in the VM, and I'm going to read this to you. So because I'm assuming it's actually wait, hold on, yeah, I forgot I had this. So we give it a URL in the XML that it generates. It already has the URL of your C2 server and the channel. It downloaded the stage, which is a zip file containing the IronPython DLLs and the main.py source code, IronPython source code of that's your actual payload logic, right? And it then automatically resolved all of the assemblies that it needed from the zip file, and then it executed the main.py file in the zip file. Hopefully that makes sense. And from there, you have a session. And it shows you nice and pretty like on the UI. And now you literally have a scripted access to .NET. So I'm going to show you a couple of things real quick. So the modules. Right now, because the font's really big, there are only a handful of modules just because I was impressed. I was just excited that this even worked, let alone finishing in time for a talk. So there's MessageBox, which I'll show you first because it sort of shows you some of the capabilities of this. There's the PowerShell module, which executes arbitrary PowerShell But that kind of defeats the purpose of this whole tool, but I thought I'd put it in there because you can call PowerShell from IronPython, but that defeats the purpose of using this in the first place. The shell command, there's Mimikatz, which is awesome, and I can't believe that even works. Excel shell inject, which I told you earlier, injects shellcode via Excel COM objects. And the MSIL shellcode injection, which is basically a port of MacGraber's and Xorior's technique of basically executing shellcode via crafted MSIL opcodes. And it doesn't call, and the great thing about this technique is that it doesn't call the standard Win32 API calls associated with shellcode injection, so it goes by a lot of stuff. And the ExecuteAssembly module, which is awesome too. So I'm going to show you, first thing I'm going to show you is the MessageBox one, because it demonstrates really easily a lot of capabilities of this. So use MessageBox, options, and all modules require a set of options. In this case, this is going to pop a MessageBox. Once you have a session, which we have here, and I sort of modeled it, I tried to build this against like Empire and MessageBox. So like some of the features of MessageBox and some of the features of Empire are in this framework as well. So, the great thing about Silent Trinity is that actually it tells you the last check-in time. So like Cobalt Strike, I tried to model this against Cobalt Strike too. So it has a last check-in time, which is really, really useful. So let's just execute this MessageBox function, this MessageBox module. And you can do RunAll to run this module against all sessions, but I only have one session now, so obviously this is only going to work here. So there you go, MessageBox. So that's really boring. But how about this? RunAll, 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 RunAll. Another one. And there you go. There you go. So that's going to do it 5 times. So since we have access to .NET, we can make the client completely asynchronous. So if you want, you could just hit RunAll, like you can stage jobs, it'll put them in a queue, and then every time the actual client, I guess, calls back, it'll just execute the jobs that you queued up, which I think is pretty cool. So it's sort of like Cobalt Strike in that way. And the great thing about that too is that whenever it's almost like real-time result. So like the minute you hit OK, like it sends the results back because the calling message of a box is a blocking function. Each job gets run in its separate .NET thread. So every time you hit OK, it just returns the function. And in this case, we're just returning pops back to the server. All right, so let's actually look at something interesting now, right? So there's the ExecuteAssembly function, and this is awesome. So all of the CSharp stuff that's been coming out recently, if you really don't want to port it over to IronPython and write modules for this, you can just compile that and run it through Silent Trinity. So let's take a look at that. Execute. The actual module names aren't auto-completed yet, but I can fix that. And all this module requires is the assembly path and the arguments you want the assembly to pass to the assembly, right? So set assembly, and in this case I have a precompiled version of seatbelt here, and if you're not familiar with seatbelt, it's just like a bunch of checks. It gives you a lot of situational awareness, host situational awareness. It's from the SpectreOps guys. And I'm just going to run this real quick. There you go. So this is the output from seatbelt, and this is it staged the assembly over the network, encoded it via 64, executed it in memory, and sent back the output. So I didn't really give it any options here, but let's set our users. Oh no, it was a user. And there you go. So that's the output of seatbelt, and I just told it to run all the user triage checks. And that's awesome, right? So we can dynamically execute assemblies sort of like Cobalt Strike through C#, through an IronPython engine, through another embedded IronPython engine. Yes. And I'm pushing my luck here, but how much time do I have? I think I'm really low on time. But I just want to show this, and then I am done. Let's see if I can. Because we all want to run Mimikatz, right?
Yes. Yes.
Come on. UAC. I should have implemented UAC bypasses here. There you go. Okay, so. Okay. Type faster, type faster. Okay, there you go. So I'm gonna. Sweet. Okay, so I just executed the MSBuild file again as admin so that I can actually show you Mimikatz. And we got another session connected. If we go to the sessions, list them out, it's sort of like Empire, so you'll be at home here. It'll give you like a little asterisk in front of the username so that you know you're running in the high integrity context. You can then go over to modules, list, use Mimikatz, options, run RunAll. Yeah, sure, why not? And there you go. So, just to recap here, we've run Mimikatz completely in memory through a CSharp binary, through an IronPython engine, through an embedded IronPython engine, by reflectively loading an assembly that injects the Mimikatz binary in memory. Just to show you that I'm not cheating here, this has been turned on the entire time. I think it's pretty cool. Oh boy. Am I over? Oh, okay.
Started late.
Okay. Oh, okay. Yeah, I guess I'm opening for Vanilla Ice. I forgot about that.
You have 3 minutes.
Okay. I'm going to try to get this back to presentation mode as fast as possible without screwing it up. Does this work? Yes. Okay, let's talk about detection real quick. Because, let's talk about detection. So, unfortunately, because there's no optics into the CLR or the DLR, the only real, and I've run procbon on this thing, and this is why I sort of want to talk to people here, because and maybe more forensics people can find something that I missed. The only really defense against this right now is defense in depth. So have whitelisting, have egress filtering, have an EDR or something like that, and most of those things will make it harder to even execute this in the first place, right? Other than that, there really isn't a lot to detect on. If you're instrumenting your payloads properly, because again, like I said, the generate function, which is the equivalent of add type in PowerShell, that does compile stuff through csc.exe, which means that you'll see processes spawn as csc.exe being spawned, and there will be files dropped to disk, temporary assemblies that csc.exe uses, but you can rename those. And so the thing is, if you're triggering on temporary DLLs to disk, that's a fragile detection mechanism, because you can just set an option that will rename those DLL assemblies. IronPython DLLs are sort of an IOC now. Like, I'm not sure if there's a good way of inspecting. There probably is. I just don't know. But there's a good way of inspecting all of the memory of every process and seeing if the IronPython DLLs are loaded. I'm not sure. That might be a way. So if you're sure you're not using IronPython in your environment, you probably should look into seeing if you can get to just not let those load at all, which might be a problem in itself. And like I said before, the code DOM stuff is fragile detection, so I wouldn't recommend that. Really, just Microsoft, please implement optics into .NET. That just solves most of this, I think. But even then, I'm not sure if that really works. Prior work. I just want to give a huge shout out to Dmitri. Dmitri Shnevshkov. I hope I'm pronouncing his name right. I highly recommend you look at his talk called Quick Retooling in .NET for Red Teams. This is my favorite talk of the year. Like, he is amazing. The stuff that he talks about in this talk is really, really cool. And he actually did some of the prior work on this IronPython stuff. That he did mention some of this IronPython stuff in his talk, and he's got a really cool project called Typhoon out there, which did some of the work that I just put together, like a lot of stuff here. But he did like the initial proof of concept, I think, on this, and he released a tool called Typhoon. So future work, more comms. The server side of the Silent Trinity actually supports HTTP2 and WebSockets as of right now. It's based on Port, which is like a new version of Flask, if you're familiar with Python web servers. So the server side is ready. The problem is .NET. .NET doesn't, at least to my knowledge, does not have an HTTP2 client available. It actually recently added a WebSocket support. So I just have to, get that going. But so more comms. I want all the comms. More modules. RESTful API. I'd like to port Death Star over. If you're not familiar with Death Star, it's another one of my projects, and basically automates gaining domain admin in Windows Active Directory environments using Empire. I'd like to port it over to this because I think that would be amazing, but that would require me to finish like all the modules in order to do that. I'd like to make it work on .NET version 4.0. I figured out a way to do this. Apparently, if you generate the C# code via IL, which is what the official IronPython compiler does, there is an actual official IronPython compiler that generates an exe stub with IL code, and it references the IronPython assemblies. And apparently, if you do that, you can just run the IronPython assemblies on any version of .NET. And I tried it, and it works. So you can run IronPython on any version of .NET. The problem with this is I would have to modify the compiler, which is actually more trivial than I initially thought. You just have to find the right IVM API calls, which is what it uses to actually generate that IL code. So I'm going to figure that out. Python object proxying. There are actual Python RPCs out there that have RPC clients in C#. Pyro, I think one of them is called. That would be interesting. So instead of just like sending IronPython files over the network, you just be proxying IronPython objects over, which I think is also pretty cool. And I'd also like to add support to actually running normal Python scripts through it. So like with the standard library, so you can like push down responder to the endpoint, which would be kind of cool. Need some more IronPython action. Thankfully, there are other people that are talking about this because at least it validates. I'm just not crazy. At least it validates my stuff here. Tomorrow from 9 to 9:50, there's a talk by Jim Shaver, building an empire with IronPython. So if you're interested in this, he's probably got some cool stuff with this as well. Credits, all these people, Comber.io from SpectreOps, I think he worked at SpectreOps, that wrote the Sharpsploit toolkit. OP Nomad, Dmitri, thank you so much for your talk. It was awesome. Egypt, which pointed me in the right direction on a couple of things that I need to resolve with the Mimikatz module. And the usual suspects here. Xorio, GentleWiki, Subt, Enigma, Manifestation, all their work. Amazing.